I'm going to talk about a subject in the engineering degree, the telecommunications engineering degree, called Continuous Communications, or the Telecommunications strand of our ICT engineering degree. And it's a subject in which, well, this is really IRIL rather than IRIL. This is about integrating inquiry into a subject, and in particular into the laboratory program within that subject. So the whole subject this semester was taken over by Keith Williel last semester, and it was part of a Learning 2014 experiment, if you like, where the class was flipped from what it had originally been, and I was lucky enough to be to volunteer to take on the laboratory component of the course and redevelop that. The subject itself is a technical subject. It's more about technology than engineering, or it's more about science than engineering, if you like. It's more about maths and understanding concepts that will help you later or help you in other areas of engineering. So it's very much a technical subject, and I've written up there push subject. It's a subject that traditionally we just told students a lot of information and expected them to learn it, and then maybe they repeat it to us in exercises, and then in later subjects, for example in project subjects, they use that sort of information to be able to solve problems. And I noted they were pretty good at that. It does deal with some important concepts for telecommunications engineers, and I won't go into these in detail, but it's important for telecommunications engineers in the current state of engineering to understand and be able to be comfortable with representing signals both in the time domain, as a function of time, like my voice is, but also in the frequency domain. It enables a lot of analysis and design to take place. They also need to understand concepts of bandwidth, noise, and the trade-offs, which is essentially the basis of telecommunications engineering. Nearly all the questions we have to look at in telecommunications are about the trade-offs between bandwidth, noise, and signal strength, and modelling and its limitations. Engineers obviously make a great use of modelling, and models have their limitations, and it's important that students understand that they have their limitations. We use them because it simplifies things for us. We can make decisions based on models. It covers up for a lack of information in some places, but it enables us to make decisions. But we need to understand that it's a model and it's not reality. In the past, the laboratories were typically isolated, time limited. You know, here's your lab, you've got 3 hours at the end, give it back to us and we'll move on. And what I've noted in previous subjects prior to this subject, that students encountered prior to this subject, that students were often overloaded. They were distracted by things that weren't related to the concepts or the outcomes that we wanted. So they were distracted by how do I use this laboratory equipment. If that wasn't one of the objectives of the subject, they were spending too much time on that, or using the software. They were distracted from what we really wanted to do. So it was my aim, or our aim, to try and change that. Students weren't getting it. They needed more opportunities to learn. They need to be able to concentrate on what's important. And also, by taking the inquiry-based approach, we were really modelling engineering thinking. It's a strange thing to call it engineering thinking. I always get embarrassed when I say that, but there are a lot of people in the world who think there is such a thing, well, a lot of engineers in the world who think there's such a thing as engineering thinking, the way that engineers think. And it is about asking questions, expansive at first, and increasing ambiguity into a point where you say, okay, now I sort of have an understanding of what's going on, and then coming into an answer rather than just going straight to the answer. And so, because of all this, I wanted to do it in a different way. And I found this image some time ago. Well, actually, I drew that image, but it's based on an image I found, and I couldn't remember where I found it, but I found it where I found it just the other day. It's in a book that's actually called Effective Inquiry for Innovative Engineering Design. But basically what it's saying is the old way is this one on the left, the exclamation mark. You start somewhere and you go straight to a result. If you're getting it wrong, you'll always get it wrong. If you're getting it right, well, you might still get it right, but you won't know that you've got it right. You'll always end up at the same place by a direct route. Inquiry-based approaches are more like this question mark, where you go off and you look around and you do finally get there, but you ask questions all the way through, and this is what we try to introduce into the course. And if I can just show you the examples, you don't have to read all this, I'll read through the couple of important bits. This is the old lab. This is one of the old labs that was used in this subject. You get a picture of what the lab experiment's going to look like. You wire it up like that, and then T1, first patch up according to figure 1, but omit the input X and Y. Connections to the multiplier. Connect the two oscilloscope channels to the scope selector as shown. T2, use the frequency counter to set the oscilloscope, etc., etc., etc. So it gives you step by step what you should be doing. And students treat it that way. You know, if you can read, you can succeed in this experiment. It's got nothing really to do with what you're trying to learn. It may, in the end, you'll see pictures on the screen that may help you understand what you've learned in a lecture previously or somewhere previously. We wanted to integrate that, and we took the task now. You're required to develop a TIMS-based demonstration of various AM modulation, demodulation. That's basically what we've asked them to do. We haven't given them the setup, we haven't given them all this sort of, now do this, now do this, now do this. So we're asking them to do this, and we're asking them to do this for 3 experiments through the session, through the semester. They spent more than half their time in the lab, about half their time in the lab, and they also had access to other labs. So we asked them to design the lab. This is where I think I didn't do very well. We tried to support them in managing what they were doing. So we didn't want them to go off, as is possible, into unknown land without some sort of help from us. I mean, I thought I had a role, but I'm not quite sure what it is yet, but I thought I had a role in helping them coming to some kind of answer. But we wanted them to look around, to ask questions, to answer, and it was done in groups, so we wanted them to do this sort of expansive questioning. But I wanted to be on top of that, so I tried to look at that a bit as well. We also expected or asked them to look at the problem as part of the laboratory, or part of designing this thing. I wanted to see what helped them design it, and I wanted to see some artefacts of that. That included a theoretical analysis of what they were doing, simulations of what they were doing. I also gave them some other material, so I gave them some inverse problems. I gave them some outputs of laboratories and said, well, or outputs of signals and said, how was this generated, and to try and get them to understand these important concepts. Shirley was mentioning before, the problem of having lecturers. I guess what we found in this subject is the problem of having lectures, tutorials and labs, which is what our timetable system says we have basically. And this was a session that was very much an integration of all those things. There were just-in-time lectures or lectures on the spur of the moment when enough students had the same problem. There's obviously a tutorial component in that we were talking a lot about things, and they were sitting with the laboratory equipment while they were doing it. The traditional approach is you do the theory, you rewrite the theory, you do the lab to demonstrate it. We were saying you've got access to all of these things at once. You can start with the laboratory and then work out what's going on. So you can come at this in multiple ways. So there were many different answers, or several different answers that you could come up with. There were many different answers. There were several sensible answers, or elegant answers. And that was good to see that students did come up with different approaches to this. The approach encouraged inquiry. And sitting in the room, and I spent a lot of time observing this last semester, and listening to them and talking to them, you could really tell that they were questioning things, or many of them would come to some of the more strategic approaches in a minute. And it encouraged collaboration, so it was much more collaborative than the old task where connect A, connect B, connect C, which is collaborative, but it wasn't in the same way. There weren't arguments really in that case, other than hang on, that's A, not B, which didn't really help. Encourage people to make decisions eventually, and to reflect. Judgment and decision making again is one of those important parts of engineering thinking. That's what engineering is about. I provided a lot of extra help where I could. So we had, I had made a number of videos about how to use the equipment, how to write simple MATLAB code to do certain things. I gave them examples of other systems and how you might calculate or do those sorts of things. We also had a remote lab. Shirley had a picture of it very briefly, where students could actually log in and play with an oscilloscope. It's only to teach them how to use an oscilloscope, but they can do that in advance. We also have a learning and design centre where we had all the equipment available for the students, just one set of it unfortunately, or 2 sets, but available to them one complete set for the students to go up and use that whenever they want, so it's available 12 hours a day at least, about 12 hours a day. Okay, where I really want to get, and I've only got 5 minutes now, of what I thought happened during the semester. I made some notes here, and because I usually make notes like this, I've got no idea which is note 1 and note 2. People who know me know that I can hardly ever get to the point in the right order. But I think it was generally successful in encouraging students and encouraging their learning. We did get generally positive feedback for the laboratories. We got some interesting feedback for the subject overall. Again, it was a big improvement on previous feedback, but there were some students who were really challenged by this approach, particularly the flipped learning. You know, I know 50% of this, why can't I pass? You know, I know one half of the subject, I should be able to just pass on that. You know, why don't you tell me? In fact, one of the bits, well, the only really negative comment that came back from the students, and I've got to tell you, this is a small class, there's only 35 students, maybe less. Trains the lab demonstrator, she never knew the answer, continuously had to ask Tim. Now, firstly they spelt new, N-E-W, which I thought, well, I don't know what knew the answer means, but what they were saying basically was, I said we don't answer all these questions, and maybe that was a mistake, and maybe we've got to answer more questions, but I said, answer questions about the equipment, answer questions about the things that are distracting students from understanding the concepts, but answer the questions with questions when they ask about, you know, how do we do this? And clearly at least one student was very frustrated with that approach and took the time to spell new, N-E-W. I think they did get a better understanding of the subject, and one of the shocks I had when I undertook this subject was this prior learning issue. I had thought that the students, because of the subjects that they had done and passed, were far different from what I found. I thought they knew a lot more. They understood the background a lot better than in fact they did when you asked them to do this. And you know, the students have been doing the subject for many years and passing, and they struggled this time round. We did work our way. They struggled. Also, I think the experience they had in effective inquiry and their understanding of their learning, I think that will help them in the future. And it's a pity that that wasn't happening, in my view. It's a pity that that wasn't happening in the subjects that led up to this. And that's one of the problems I think we have with introducing different approaches that students aren't used to. And it's so late in the course. This is 2/3 of the way through their course, or halfway through their course. I think our approaches to assessment were better. This wasn't, you know, you hand it in and you get a mark out of 100. This was, when you're ready, come and show me, and if it's satisfactory, and if you can demonstrate it, you'll get all the marks for that particular component. There were some little bonus mark things, not quite sure why I had those, just for a bit of fun, I think. Well, no. There were students who wanted to do more than just the lab, so we allowed them to do that. But to do the lab, they just had to demonstrate it, answer questions, you know, the group of 3, one of us, one of me, asking them questions about their understanding, and you know, showing me through their working and what they were doing. And I think that was better than a simple, you write it all up, you hand it in and you get a mark out of 10. There was feedback during that as well. And if they weren't right, they had a chance to do it again. It wasn't as though, the only thing that limited them was the end of the semester. They could do any of the labs right up to the end of the semester, and again that introduced another problem. The approach challenged the students, I think, in that it did test their prior knowledge, it did test their prior learning, it tested some of the concepts that they thought, or that they had managed to demonstrate to us in the past that they understood, and clearly they didn't, or they didn't understand it well. There was a considerable amount of frustration because they thought they were being asked to do too much. They wanted labs like the old labs. They really wanted to see labs like the old labs. And a lot of their questions were a bit like that, you know. Okay, now what do I do? When they finally get it said, oh, it's not working, Tim, how can I get it to work? I spoke to Les about that, and Les says, well, I can get it to work, but that's not much good to you, is it? You have a go at getting it to work. So, you know, they learned some stuff there, but they've got quite frustrated about that from time to time. Poor time management, because I said, you've got all semester to do this, and there were 3 labs, and I gave them a little, in the lab handout, there was a little thing about time management. If I was you, I'd do this one by week 3, and this one by week 6, and this one by week 9. Well, a few did that, but most of them kind of had all sort of concatenated towards the end, and that made it quite difficult for them and for me, because it meant that I was going to the lab, you know, every day for a few hours to assess these things, and that's not sustainable. The other thing they found difficult is the strategic approaches that they previously used didn't work in this subject. So developing a fairly shallow understanding and applying it didn't convince us. And so they found it difficult, I think, in that respect. My time's up, isn't it? It's okay. Some of the other things I think I need to understand as a staff member in this, is I need to understand better where the students are when they start this, so that I can provide the right support, I think. And I'd rather the students were somewhere else than they are now, but that's a much bigger question. Being clear about the expectations, letting the students know, their strategic approach, by the way, is I'll Google this and I'll get an answer. That's always worked. Now they Google it and they get an answer, and then when they have to explain it to me or have to implement it, they find it much more difficult. And I'd say one of the things was show me some MATLAB code. Now, the MATLAB code really was 2 lines of MATLAB. That's all they had to do. But they download a 5-page program, and then they say, oh, this is how I demonstrate. And I said, well, how does this work? No idea. So, there were some issues with that. That's have to be clear about expectations right up front. I thought I was, but they still didn't understand them, and I guess that's a matter of changing everybody's culture. I was worried about the way we facilitated this. I don't know when you answer questions, when you don't. I don't know. I was always a little uncertain about my role in this and where I should be emphasising things and not emphasising things. I think we got some bits right, but I think we can improve a lot. One of the things I tried to introduce was that students would upload a resource. I was trying to develop for over time a repository of student-found resources that they would manage themselves over time. So they'd be saying, well, these are good and these aren't good. Again, they took the approach of Google it, find the first article you got, put it up, write a 3-line critique of it rather than what I was wanting, and that was enough. So I think, again, that comes to expectations, but also getting the resources. Challenges, relationship with other subjects. I've sort of mentioned how does this fit into a course that's not typically like this. There are subjects within this, and by the way, what I did, I'm sure that many of you are already doing. It's just it's not that common in many of the engineering subjects. And the other problem, of course, but is sustainability of this. Students will soon realise, unfortunately, if you give them the same problem every semester, and we're trying to just deal with a small number of particular concepts, that if you look at what people did the last semester, you'll start to be able to do it. So maintaining that challenge and making it useful to students. I've got a couple more semesters in me, but after that I think somebody else will have to come up with the ideas. That's it. Thank you.
Sorry, I want to ask a question here. I think you touched on something which is really important this year. This subject was 2/3 of the way through the degree. What, half or 2/3?
Well, it depends. The students can do it at different places, but it's tougher for it. Yeah.
And what I got from your message, what you said was that the previous experiences were what you might call traditional experience, and so they weren't mentally prepared, or not just the background, but the sort of experience you're living. I mean, does this mean that you to work backwards through the curriculum to get more people on side, so that because there's always be a problem that you'll be seeing the rabbit in the headlights sort of when you give them this particular activity, that they're not ready for it because of the way they've been prepared or not prepared.
Yeah, I mean, I think there are subjects in our course that do ask students to think, and there are a lot of them, but it's bringing that kind of technical stuff together with that they're not experienced that. So they've done something before this on signal theory. The signal theory should have been pretty straightforward. Now, Fourier transforms should have been something they could do quite well on this subject and give them a feeling for those different domains, but they didn't understand it. They couldn't do it basically, so there was a lot of reteaching. Or rediscovery for them. And I think if that subject had been taught in a different way, maybe they would have come through with their understanding.
I guess that I'm getting at this previous subject. If it's sort of here are the notes, memorise this approach to doing Fourier transform, where it is. And things are going to get better, I guess, because they're not learning it because they're getting 51% and off we move to the next subject.
Look, we have program. I agree, and I think that the ICT program that I'm in is probably one of the ones that's in most in need of change. Surith's here, and he's been involved in the development of a mechatronics degree, which has these sorts of subjects all the way through. Not every subject's like this, but of course they're all the way through. students are getting more experienced with this kind of approach to this more
Open-ended.
Open-ended. Yeah.
I'll let Anna question.
My question was sort of along similar lines. How do you put a bomb under the people responsible for the subjects previously so that their assessments do mean that the students don't get through unless they really do know the material?
I wish I knew an answer to that. I've been searching for it for the last 5 years. We've taken some pretty brutal approaches in some areas. It is a staff development issue. It's also a workload issue. One of the problems with this, with changing subjects, is people are quite comfortable with what they're doing if they get reasonable even if they get good student feedback. There are not a lot of. I really don't know the answer to that. I think where staff are working together on courses, you've got a much better chance. And this is where, again, I point to Sereth and Terry and the others who have been involved in developing that. And I think there's some of that in the, maybe in the environmental area. You know more than I would. But, you come right back to some of the faculty's real problems of the schools versus the subjects versus courses and that whole kind of thing, and also the value of teaching. It's a big problem.
Tim, how did you deal with the students? Because it's a very open-ended task.
Yes.
So did you find that the students felt overwhelmed by that?
I think they were initially overwhelmed, and what I did is I put up some examples of a different kind of experiment, or actually an experiment that they could have done before this one, of how I would have gone about it. And that helped them, I think, in many ways. Like, this isn't a really complex task. It's just a little bit open-ended in that there's more than one solution. There's more than one way of getting to that solution. The only one that they really had trouble with was the Laboratory 3, the third one in the series, which was actually much more challenging. And only a small number of students actually attempted that laboratory. It wasn't a compulsory component of it. They didn't need to do it to pass. And that proved to be quite a difficult one. And again, that's a lot to do with previous knowledge. I had assumed that by halfway through an engineering course, students had built a circuit, put together a circuit. In fact, I know they had in their first year subject, but they'd forgotten these skills or they hadn't learned these skills. We've got questions everywhere.
Rob?
Do you think that...
Sorry, Rachel. Exactly.
No, go.
Do you think they genuinely did not understand, or whether or not it was the classic student denied learning?
Did the students really not understand, or was it the classic, we've never seen this before approach? No, they didn't understand. I'm certain of that because I spent a lot of time with them. And they explained why they didn't understand. They said, in the subject where we learned about Fourier transforms, we did these exercises and we knew the exercises would be in the exam, essentially the same. And so it was a very strategic approach to passing the subject. And that's a problem.
That is a problem.
Can we get one more question, Rob?
Sorry, you may have answered this and I was missing. Was there a correlation between the students that came up with elegant solutions to your open-ended problems and those that you think may have demonstrated really good technical outcomes and stuff you're looking for in exams or in other areas?
It's interesting. I haven't looked at that. I know that the student who did the best in the subject basically took that exclamation mark approach because they knew all this stuff already. And they took the grip along. It was kind of disappointing in a way that we couldn't challenge him a bit more. He actually did the third task and did it quite well. But so he got the top mark. But he kind of knew the stuff before he started, which was a bit unfair. But he did help the students in his group. They worked quite well. What I did notice, there was another group that weren't these fantastic students, but their engagement was incredible. They were the ones who came to the LDC. They were the ones that did everything. And they did very well in the subject in the end. They genuinely learned something, I think. Initially, about a third of the students actually failed this subject, but Keith, being Keith, ran the subject for 5 extra weeks after the semester finished, and something that not many of us can afford to do. Gradually brought many of the others up to a pass through a supplementary 5-week process.
Okay, can we thank Tim?